Hello and welcome to part 2 on the peach series. In this episode, we'll talk about the history of cultivar improvement in peaches, as well as some cool Frankensteining explained later. First, let's talk about genetic improvement. Peaches were first mentioned 4,000 years ago. They then arrived in Greece from Persia around 2500 BP. They then came to Rome 500 years later. The peach populations then went to Florida, Mexico, and South America in the mid-1500s via Spanish and Portuguese explorers. Peach production expanded rapidly during the Industrial Revolution. Prolific fruit tree breeders such as John Rivers produced many cultivars. Many cultivars were propagated by cloning, although a few may have been seed-produced. Peach breeding in North America started 100 years ago. The breeders over there utilized two sources of germplasm. One source was the cultivars of England. The other source was the feral and cultivated varieties of South America. Until the American Revolution, peaches were mostly produced from seedlings of very low quality. The first clonally produced trees were produced and sold by Robert Prince before the Revolutionary War. These clonally produced cultivars were later sold by John Kenrick in the 1790s. During the first half of the 1800s, a number of cultivars of unknown origin were released. These include Early Crawford, Late Crawford, and Old Mixing Cling. In the 1850s, Charles Downing released the Chinese Cling cultivar from China to the US. Using Chinese Cling, the new varieties Belle and Alberta were bred. The cultivar Hiley was likely a seedling of Belle, and from Alberta, J. H. Hale was produced. Most breeding activity was produced from these two cultivars. Peach breeding began in earnest in a number of state experiment stations in the late 1890s and early 1900s. These programs were in California, New Jersey, and the USDA. Stanley Johnson of Michigan began a large-scale breeding program in 1924 and developed the Red Haven peach, which dominated peach cultivation in the eastern United States for several decades. Many other large public programs for breeding were done in Arkansas, North Carolina, Louisiana, Texas, Florida, and North Carolina. In my home province of Ontario, Vineland produced many peaches as well, since 1914, along with another research institute called Hero, also in my home province of Ontario. Since the 1960s, peach breeding efforts have also been taken in Argentina, Australia, Brazil, China, France, Italy, Japan, Mexico, and South Africa. In the middle of the century, several breeding programs of private origin emerged in the United States. This included Grant Morrell, F.W. Anderson, and Armstrong Nursery Company, as well as various public companies such as Zyger Genetics, Meltzler and Sons, Bradford and Bradford, Paul Friday, and Fruit Acres. Now let's talk about current breeding efforts. Peach breeding activity has been very high over the last decade. Dr. Sansavani has called the 20th century the golden age of peach breeding. The private sector has been responsible for most of the new peach cultivars, although a few canning varieties have been bred in the public sector. When it comes to current peach breeding, 55% of the peach cultivars came from the United States, and 30% were bred in Europe, with Italy and France taking the lion's share of the breeding work. Most of those cultivars were yellow flesh peaches and nectarines, although a number of white flesh cultivars have also been developed in France, China, Japan, and South Korea. The main improvements found in modern peaches include larger fruit size, improved skin aesthetics, improved flesh to pit ratio, and the ability to harvest peaches 4 to 6 months out of the year rather than 2 to 3. Breeding to expand the range of peaches has also been a major priority in peach breeding. Examples include reduced chilling requirements so that peaches can be grown in subtropical environments, such as parts of Spain, France, Italy, the United States, and China. There has also been breeding to increase frost tolerance through the breeding of late-blooming peaches. This is useful in colder climates such as Canada, Poland, and Russia. There has also been breeding programs to improve the flavor of peaches. European breeding programs have worked on improving the flavor by reintroducing old flavors found in ancient cultivars. Chinese breeding programs are interested in low-acid variants. Firmer fruit are also being bred for within peach programs to improve shipping and handling. This is happening primarily in Chile, South Africa, New Zealand, and the United States. There has also been breeding programs to reduce the size and vigor of the plants, to enable mechanization and reduce the cost of pruning, thinning, and harvesting. There has also been plenty of breeding for disease resistance, such as diseases like PPV or plum pox virus, powdery mildew, brown rot, leaf curl, and the insect pest green aphid, the vector for PPV. In many locations, rootstock breeding for peaches is high priority, such as areas with nematodes, bacterial and viral diseases, as well as alkaline soils. Next, we'll discuss how rootstocks can be bred for growth in alkaline environments. One cool element of Frankensteining in peaches is the almond-peach hybrids. These crossbred hybrids have greater tolerance to calcareous soils, commonly found in the Mediterranean areas. These rootstocks are also highly vigorous, helping out in marginal soils. These hybrid rootstocks are also compatible with both peach and almond. This makes peach-almond hybrids useful for rootstocks in certain areas. This concludes my series on peach. Next up, plums. Hope to see you then. Cheers.